bonding. To learn the concept of chemical bonding, consider daily life example like table salt. Now, do you know that table salt is an example of compounds? Compounds are chemically substances made up of two or more elements that are chemically bound together. One good example is sodium chloride or the table salt. Do you like bonding with your friends, family, or loved ones? Do you miss bonding with your classmates? Bonding as humans are very important in our social life and emotional state. Moreover, do you know that atoms bond as well? And that is what we call chemical bonding. Chemical bonding is a lasting attraction between atoms, ions, or molecules that enables formation of chemical compounds. So, we say that it is the chemical bond that is making everything around us. In simple words, we say that chemical bond is just like cement that hold two bricks together. Therefore, note it down that chemical bond is the attraction force between ions, atoms, and molecules. In demonstrating the bond formation, Gilbert Newton Lewis or Lewis dot symbol is used. There are two types of chemical bond, the ionic bond and the covalent bond. Now we will all learn ionic bonds. Ions. As you already know, ions are formed from the loss or gain of electron. Electrons, however, do not suddenly appear or disappear. They are in fact transferred from one atom to another. Let's look at sodium and chloride as an example. Sodium loses one electron to form a sodium ion. The electron is not lost, but transferred to chlorine to form a chloride ion. So we have a sodium ion and a chloride ion. They are oppositely charged ions and will be electrostatically attracted to one another, much like how opposite poles of a magnet are attracted to one another. This electrostatic attraction is an ionic bond. Sodium chloride is an ionic compound because it is held intact by ionic bond. The same thing happens with magnesium and oxygen. Magnesium transfers two valence electrons to oxygen, forming magnesium ion and oxide ion. The resulting ions are electrostatically attracted to one another, forming an ionic bond.
Good day everyone, I am Hannah Jane T. Duterte and I am going to tackle about the covalent bond. So the covalent bond is where two or more atoms share electrons. The sharing of atoms help complete the outer shell or valence shell of both atoms. For example, oxygen has 6 valence electrons. It can form a covalent bond with two hydrogen atoms, each of which has a valence electron. So how can we identify a covalent bond? Covalent bonding takes place between two nonmetals by sharing of electrons. So this is our examples of covalent bonds. The identification of covalent bonds can be done by electronegative difference. The electronegative the molecules will be between 0 to 3. Then the bonding will be non-polar covalent bonding. Most compounds having covalent bond exhibit relatively low melting points and boiling points. So most of the covalent bonds exhibit relatively slow or low melting point or boiling point. So it boils immediately as you express it in a hot surface. Compounds with covalent bonds usually have lower enthalpies of vaporization and fusion. Compounds formed by covalent bonding don't conduct electricity due to lack of free electrons. 5 examples of covalent bond are hydrogen oxygen, nitrogen, water, and methane. What is a covalent bond? A chemical bonding involving the sharing of electron pairs between atoms is known as a covalent bond. So as I said that a covalent bond is a sharing of two electrons of an atom. So the covalent bond is also called molecular bond. So we can identify a covalent bond if two nonmetallic elements, like for example, both hydrogen and oxygen are nonmetallics, and when they combine to make water, they do so by forming covalent bonds. So there are two basic types of covalent bonds, polar and nonpolar. In a polar covalent bond, the electrons are unequally shared by the atoms and spend more time close to one another. Another way Another way atoms can become more stable is by sharing electrons, thus forming covalent bonds. Covalent bonds are more common than ionic bonds in the molecular or living organism. For instance, covalent bonds are key to the structure of carbon-based organic molecules like rDNA and proteins. Covalent bonds are also found in smaller inorganic molecules such as H2O, CO2, and O2. Two, or three pairs of electrons may be shared between atoms, resulting in single, double, or triple bonds, respectively. As an example of covalent bonding, let's look at water. A single water molecule H2O consists of two hydrogen atoms bonding to one oxygen atom. Each hydrogen shares an electron with oxygen, and oxygen shares one of its electrons with each other. There are two basic types of covalent bonds, the polar and nonpolar bonds. Polar bonds bond. In the polar covalent bond, the electrons are unequally shared by the atoms and spend more time close to one atom than the other. Because of the unequal distribution of electrons between the atoms of different elements, slightly positive and slightly negative charges develop in different parts of the molecules. So, polar covalent bond distribute electrons between the atom of different elements, slightly positive and slightly negative. In water molecule, the bond connecting the oxygen to each hydrogen is a polar bond. Oxygen is much more electronegative atom than hydrogen, meaning that it attracts share electrons more strongly. So the oxygen of water bears a partial negative charge, has high electron density. So in water, oxygen has high electron density than the hydrogen, while the hydrogens bear partially positive charge, have low density. Nonpolar covalent bonds form between two atoms of the same element, or between atoms of different elements that share electrons more or less equal. For example, molecular oxygen, or O2, is nonpolar because the electrons are equally shared between the two oxygen atoms. So nonpolar covalent bonds are elements that share electrons more or less, share different electrons. Another example of nonpolar covalent bond is found in methane. CH4. Carbon has 4 electrons in its outermost shell and needs 4 more to achieve a stable octet. It gets this by sharing electrons with 4 hydrogen atoms, which provides a single electron. Reciprocally, the hydrogen atoms each need additional electrons to fill their outermost shell, which they receive in form of shared electrons from the carbon. And that's all for the covalent bond. Thank you.